So the overall equation for this unit is called the Gibbs free energy equation, and this is how entropy and enthalpy are related. Entropy is a measure of disorder, while enthalpy is a measure of heat. Gibbs free energy has a unit of G, delta G. The Gibbs free energy can be found in joules or kilojoules. Enthalpy will be in kilojoules per mole, and so will entropy. And we will look at these. Temperature also determines whether something is, how much free energy something has, because we know as temperature increases, so does the movement of molecules. We'll talk more about enthalpy separately and entropy as we move through this unit, but I wanted you to see the overall equation. So you'll see that delta G, or free energy, is equal to delta H, enthalpy, minus the temperature times the delta S. This is a new unit that we haven't seen. It's a measure of randomness, or a measure of chaos. And we'll talk more about that. Nature tends to go from order to disorder. Gibbs free energy is, again, the energy available to do useful work. Gibbs free energy tells us whether a reaction will happen spontaneously or not spontaneously. If a delta G is less than 0, then it's an exergonic reaction and it will spontaneously occur. If delta G is greater than 0, then it's what's called an endergonic reaction, and it will not happen spontaneously. You will need to put energy into the system. Again, we will discuss all of these in more detail as we move through this unit, but I wanted to introduce it. Okay, first we need to go back and think about what energy is. Energy is the ability to do work. There are two main states of energy. You have potential energy or stored energy. Potential energy can be chemical energy, energy stored in bonds. Potential energy could be mechanical energy, energy stored in elastics or rubber bands or springs. It can be energy stored in the height of this waterfall here. Those are all stored energy. Kinetic energy, if you recall, is the energy of movement. This could be electrical energy, the energy of the electrons moving. This could be energy of motion. Anything moving is going to have kinetic energy. Remember, temperature changes and kinetic energy increases as molecules move more rapidly. Okay, today I just want you to look at this, and I want to just go way back to 7th grade, 6th grade energy, and how energy, we know the first law of thermodynamics is that energy cannot be created or destroyed, only transform from one form to another. I'd like you to take a look at this picture and write down all the different types of energy transformations. We will talk about those transformations. I want you to think about everything that it could be and how it's transforming. So what kind of energy is the gas burning in the mower? What kind of energy does it take for the man to push the mower? What kind of energy does it take for the grass to grow? What kind of energy is involved to allow the man to push? Think about those things. And then again for tomorrow, I want you to look up entropy and enthalpy. And then we will continue here on Tuesday. Have a great day.